Good day everyone, I'm Ronald Mark E. Sarangaya, and today I will be telling you about what is Object-Oriented Programming or OOP. It is a programming paradigm that organizes software design around objects, which can be thought of as entities that encapsulate data and the operation that can be performed on that data. It focuses on modeling real-world entities or concepts into software objects, making the design and development process more intuitive and modular. One key characteristic of OOP is the use of objects, which are instances of classes that encapsulate data and methods. The first concept of OOP is the concept of classes. Blueprints that define common object properties and behaviors. They serve as the data containers and methods of specific objects type. Class definition promote reusability, maintainability, and code organization, making them essential for object creation. The second concept of OOP, the concept of objects. Object-oriented programming uses objects as instances of classes, defining properties and behaviors. This promotes code reusability, modularity, and organization, allowing developers to create complex systems with unique states and behaviors. The third concept of OOP is concept of encapsulation. It's a fundamental concept in OOP that combines data and behaviors within a single unit. Controlling access, it keeps an object's internal state private and exposes only a limited set of public methods, enhancing data security, simplifying usage, promoting modularity, and encouraging code reusability. The fourth concept of OOP, the concept of inheritance. In OOP allows for the creation of new classes based on existing ones, promoting code reusability and hierarchical structures. It involves a superclass inheriting properties and methods, and supporting polymorphism between classes. The fifth concept of OOP is the concept of polymorphism. In a OOP allows objects of different classes to be treated as a common superclass objects, promoting code reuse, flexibility, and efficient design of object-oriented systems, despite their specific implementations. Real-world analogy. In a zoo, create a blueprints for animals types, like mammals, defining characteristics and behaviors. Inheritance creates specific classes, ensuring consistency across related objects. This approach helps create a cohesive zoo program. First, let's create a class called Animals as the base class for all animals in our zoo. This class will contain basic properties like name and age, and we'll define it as an abstract class to enforce that it cannot be instantiated on its own. Next, let's create a derived class called Lion, which inherits from the Animals class. In this class, we'll need to implement the abstract methods, make sounds, and provide a unique implementation for the lion roar. Similarly, let's create another derived class called Giraffe, which also inherits from the Animal class. We'll implement the make sounds method to simulate the giraffe sound. Now, let's create some objects of these classes and call their respective methods to see how they behave. When we run this code, we will see the following output. As we can see, each animal object calls its respective make sounds method, demonstrating polymorphism in action. This allows us to define common behaviors in the base animal class and customize it in the derived classes. And that's it. We have successfully created classes, objects, and methods calls in our zoo scenario using C#. Feel free to explore and expand this code to add more animals or behaviors in your own zoo programming object. Overall, OOP enhanced software development by providing a well-structured, modular, and maintainable approach, allowing developers to build complex systems efficiently and effectively.